Hello friends. The previous live stream on part 1 of the surface area and volume video got interrupted in between. So here I am live again to repeat that session, and anyone who has missed the session can now join in, and we can have the same session again. Yeah, I think people are joining in now. Okay, so I was just telling you in the beginning of my previous video, which got interrupted, that if you know the meaning of area, the meaning of volume, these formulas will become very easy. But if you are confused in what area is, why the area unit is centimeter square or meter square, and why in case of volume you write the unit as meter cube or centimeter cube, then it is going to be trouble. Now see, all these formulas are taught to the students at class 7th, 6th, 7th level, and they continue up to any level through which the student is studying mathematics. So we can assume that it is an important topic, and without this topic many other higher concepts are invalid. You cannot just push them and carry forward them. Now see, this is a schematic table of what we are going to do today and understand today. This is the figure which we will be doing. This is the dimension. Now what are the dimensions? Basically, dimension is the variable which is required to understand a particular figure. So whatever variable is included in the figure, if you know that, you can apply the formula. If you don't know the variables, then obviously the formula cannot be understood easily. In the meanwhile, I welcome Kiran, Amin, Makula, Cook with Simran. I think she has also started a brilliant channel of cookery. You can always have a look at it if you are interested in cooking. Praveen Kumar, hello. Sai Kiran, Yuvraj, Kamlakar, Shalini, Kritika, hello to everyone. Okay, so I was just telling you about cube. Now see, this is actually a cube in which all the sides are same, and we have 6 faces of this cube, and all the faces are square in shape. So there are 6 squares, 4 on the sides and 1 at the top and 1 at the bottom. So these 6 faces make a cube. The only dimension of a cube is its side, which is denoted in the figure by the alphabet A. So if you know A, the side of the cube, then we can derive all the formulas. I'll just quickly do it because most of you saw it in the previous video. See, this is one square. So the area of a square is side square, that is A square. I've written it here. So if we are talking about curved surface area, then we will consider only the 4 faces which are all around this cube. So A square, A square, A square and A square. There are 4 A squares. So the curved surface area of a cube is 4 times A square. Now what about the total surface area? See, on the top and on the bottom there is another square here, another square here. So again A square and A square. So we have 2 more A squares. So 4 A squares were already there in the curved surface area, and 2 more A squares got added, 1 on the top and 1 on the bottom. So total number of A squares is 6 A square now. So which is the formula for the total surface area. Now for finding the volume of any figure, you just remember one thing, that volume is obtained by multiplying the base area, the area of the base, with the height. See, in this figure I have shaded the base and the top. Base is a square. The area of a square is a square. So base area is a square multiplied by its height. Now see, when we talk of a cube, the this side and the length, the breadth and the height all are same. So this is also a. So the height is also a. So a square into a gives you the formula for the volume of a cube, which is a cube. So these are the three formulas of a cube. Simultaneously, let me tell you one more thing. The diagonal of a cube is given by square root 3 times the square of the side. Very important again. This is one formula which is quite often missed by the students at class 9th and 10th level. So diagonal of a cube is root 3 times the area of a square. So a square into root 3 gives you the diagonal of a cube. And I'll tell you how this formula is derived. Once we come to the cuboid, we can derive the this diagonal formula from this. Now, in case of a cuboid, see, this is a cuboidal shape. This is a box, and this box has the length L. Say, if you keep it like this, and this is length L, this is breadth B. See, I have labeled it here B, and length. This is the height. So, if you see this face, this is L and this is H. So L and H are the dimensions of this rectangle. For this rectangle, you have B and H, and for this rectangle, you have L and B. So different faces of a cuboid have different area because its dimensions are different. So here I have mentioned the three dimensions of a cuboid: length L, breadth B, and height H. And I have also shaded the top and bottom faces of this cuboid. So how do we find the various formulas related to a cuboid? Now we will come to the diagonal first, because the diagonal of cuboid will give you the formula for diagonal of a cube also. So the diagonal of a cuboid is basically represented by L square plus B square plus H square square root. So if you remember this formula of diagonal of a cuboid, then you can derive the formula for diagonal of a cube. See, L, B and H. Here L, B and H are different, but in this case L, B and H all are same. So what you do? Just put L, B and H equal to A. So A square, A square, A square, 3A square. So 3A square, this is A root 3. Square was extra there. So A root 3. So this is the formula which can be derived right from the formula of the diagonal of a cuboid. Now check the curved surface area. How do we find the curved surface area? Now see, suppose this is a room shape. Now if this is a room, then just check out this wall. This wall is having the area LH. So L into H is the area of this wall, and this wall is having the area B into H. So all are rectangles. So I am just multiplying length and breadth. So for the curved surface area, one wall is having the area BH. See, if this wall is having the area BH, then the opposite wall will also have the same area. So 2BH. If this wall is having the area LH, then the opposite wall, that is this one, will also have the area LH. So 2LH. Now you can take 2 common and H common. You are left with L plus B. This is the formula for finding the curved surface area of a cuboid. So twice length plus breadth into height. See, I am joined by so many of my students now: Shalini, Kritika, Manoj, Aditya, Piyush, Makula, Bhavna, Lakshay, Ankit Patel, yeah, KK, Tolani, So please make a video on polynomials. Yeah, surely I'll get on with that soon. Okay. Now for the total surface area. Now see, 2BH and 2LH, they were already there in the curved surface area. What else you require for framing the formula? You require the area of the base and area of the top. So what is the area of the base? Just see the dimensions. This is L and this is B. So LB. So we have LB at the base and LB at the top. So 2LB is the extra term which is included in the formula for the total surface area of a cuboid. Now you can take 2 common. So you are left with LB plus BH plus LH. This is the formula for the TSA. So now you have CSA and TSA both. Volume is very easy. Again we have the same figure. Same formula, base area into height. What is the base like? Base is like a rectangle. So what is the base area? Length into breadth. So base area is length into breadth and multiply by the height h. So you get the formula for the volume of a cuboid. Up to here, if there is any doubt or any problem in understanding any of these formulas, you can ask. Okay, I think there is no problem in these two formulas. Just a recapitulation. Just see the diagonal of a cube is given by square root 3 times the side. Curved surface area 4a square. Total surface area 6a square. And volume is a cube. Likewise, if you have a cuboid, then the diagonal is under root L square plus B square plus H square. The curved surface area is twice L plus B into H. The total surface area is 2 into LB plus BH plus LH, and the volume is L into B into H. Fine. Now, after having understood these two basic shapes, then we can get on with the third shape, that is the shape of a cylinder. Usually in books, you will not find the word cylinder, you will find a right circular cylinder. Can anyone tell me why a cylinder is written as a right circular cylinder? Yeah, in your comments, please. Just waiting for your live comment as to why a cylinder is called a right circular cylinder. What do you mean by a right circular cylinder? I'm just waiting for anyone to reply. No comments yet. A right circular cylinder. Why it is called a right circular cylinder? Yeah. See, that's what is maths all about. We keep on studying so many terms in mathematics, but we don't know the meaning of those terms. Iqbal, height must be straight. Height is always straight, Iqbal. It cannot be curved. Okay. Okay, fine. Yeah, axis perpendicular to base. Yeah, quite a good explanation, but it can be little simpler, Deepak. Base must be flat. No, that is not the actual explanation of right circular. Circle and height, no. Cross section is uniform, no. Yeah, again, so see, we have so many answers, but only one answer I found little bit similar to what actually I am desiring. Base and height with right angle. Yeah, Kiran Amin. Yeah, you explained that, right? Base and height with right angle. Yeah. So we can just explain this now. See, right circular cylinder is basically having a circle at the top, then the curved surface, and then a circle at the bottom. Now see, in this, the radius of the base R, this is the radius of the base, and this is the height, vertical height H. They form an angle of 90°. The radius and height are perpendicular. That is why we call it a right circular cylinder. There can be a cylinder which is not right circular. Like, see, this is also a cylinder. Now see, this is also a cylinder, but this is not a right circular cylinder because this height and the radius are not perpendicular to each other. So I hope that clears the doubt. Yeah, so many of you are talking about the paper of class 10th being cancelled. Yeah, that's one of the events which has happened today. So we can get on with that preparation and score much better than what we would have done today. Okay, so this is the figure of the right circular cylinder. I am again shading the top face, that is the flat surface, and the bottom face, that is again the flat surface. These two faces will not be included in curved surface area. Curved surface area is only all around. The top and bottom are included in total surface area, not in curved surface area. So what are the dimensions of this figure? The dimensions of this figure are its height, which is h, and its radius, which is r. So h and r, these are the two dimensions of this right circular cylinder. Now what about the curved surface area or the lateral surface area? Now how to remember this? Just take the circumference of a circle, and multiply that by the height of the cylinder. Circumference of circle, if you know the formula, it is 2 pi r, and h is the height of this cylinder. You get the formula for the curved surface area or the lateral surface area of a right circular cylinder. This is 2 pi RH. Obviously, there are more methods of deriving this 2 pi RH formula, but for remembering the formula, you can use this particular method. That is, you can remember the formula for circumference of circle, which is pi r square, and multiply it by height, and relate this formula with the volume formula. Now, what is the volume formula? Now, it is area of circle multiplied by the height. Now here we have the circumference and here we have the area. So now these two are different. Here we have 2 pi r and here we have pi r square. So pi r square into h, this gives the volume of a cylinder. The formula comes out to be pi r square h. So 2 pi r h and pi r square h. Viewers, please don't get confused on these two formulas. This is a very common mistake done by students. 2 pi RH, there are only two variables, R and H. So in area, only two things are multiplied. 2 pi is constant, it has no units. R and H are variables, therefore the unit of area is centimeter square or meter square. So only two things are multiplied. Whereas in case of volume, there are three things which are multiplied. See, we have R square, that means 2 R's and 1 H. So 2 R's and 1 H, three things. So therefore the unit of volume is centimeter cube or meter cube. Now what about the formula for the total surface area? Now this total surface area includes the curved surface area 2 pi RH, and what else is to be written? The area of the top and area of the bottom. The top and bottom of a cylinder, they are basically circles, and the area of a circle is pi r square. So we have 1 pi r square at the top and 1 pi r square at the bottom. So there are 2 pi r squares. So these 2 pi r squares are to be added to the curved surface area for finding the total surface area. So now you can take common. What is common in these two? 2 pi r. So h plus r is remaining. This forms the formula of the total surface area of a cylinder. See viewers, understanding the formulas and then relating it with the problem will help you in solving most of the problems of surface area and volume. But if you cram the formulas, obviously you are bound to make an error somewhere or the other. Now in this video, I have dealt only with three problems, three figures, that is the cube, the cuboid and the right circular cylinder. So in subsequent videos, we can talk of the other three figures, that is the cone, the sphere, obviously hemisphere and the frustum. If you have any doubt in these formulas, or you are not able to understand any particular concept of surface area and volume, we can have a live discussion here. Anything in these formulas or in this topic which haunts you, or which is troubling you in exams, you are not able to remember any particular thing, anything? Yeah, I think most of you are aware of all these formulas, but only thing is how we remember it. So now you know the method how we remember it. So meanwhile, I'm being joined by so many of new viewers. So we can continue that this topic for one more figure now. This figure is the right circular cone. Now, for the benefit of my viewers, I'm just continuing this live streaming so that we can have one or two more figures completed in this video itself. The fourth one is right circular cone. Right circular cone. Now, right circular cone is basically this is the shape of a right circular cone. Now, in this shape, you have, what are the dimensions? You have three dimensions here. This is the radius of the base, which is a circle. So I am shading the base. Now there is no roof, flat roof. Unlike in this figure, you have the top surface as flat surface and the bottom also a flat surface. Here you have only one single base which is flat and which is circular. Now this is the height h, and in case of a cone we have one more height. That height is the slant height L. Slant height L. So the dimensions of a cone are L is the slant height, H is the vertical height, and R is the radius of base. Now, how to remember the formula for the right circular cone? Now, what about the curved surface area? Now, when you talk of curved surface area, then it is a very simple formula which needs no method to remember. In the formula for the cylinder, the formula for curved surface area is 2 pi RH. So just forget this 2 and replace h by the slant height L. You will know the formula for the curved surface area of a cone. And you can very easily convert this formula into total surface area now. See, total surface area includes this pi RL. Pi RL is obviously their curved surface area. And what else will come here? The base. So base is circle. So area of circle is pi r square. So here we have two pi r squares, one on the top and one on the bottom. But here we have only one pi r square, that is on the base. So here we are adding only one pi r square to pi r L. So now you can take common pi r L plus r. That is the formula for the total surface area of a cone. Now see, here we have three dimensions, h, L and r, and if you can see very clearly that these three are forming a right angled triangle. So we can have one more formula, L square equal to h square plus r square, which is the Pythagoras theorem. Now this is the Pythagoras theorem, L square equal to h square plus r square, which is used to find one variable when other two variables are given. So if you know h and L, you can find r. If you know L and r, you can find h. And if you know h and r, you can find L using this formula. Now what about the volume? Just compare it with the volume of the cylinder, which is pi r square h. and put a 1 by 3 in front of this, because the volume of a cone is always 1/3 the volume of a cylinder if the radius and height are same. So just put 1/3 in front of the formula for the volume of a cylinder, you will get the formula for volume of a cone. So this covers our 4 basic shapes, basic solids which are no, which are there in the syllabus. Now one question for viewers. Yeah, we will have frustum, area of frustum later, surely. We'll have it in the second part of the video. Yeah, I know most of you already know all these formulas, but I'm just telling you how we can remember these formulas for life. And obviously, at some stage, we have to teach them to different people. So if you deal with others, you can tell them these ways of remembering the formulas. There's one question for you all. What is the difference between 2-dimension and 3-dimension? Why we call a shape as 2D and why we call a shape as 3D? Can I have the comments, please? Why we call a shape as 2D? What does D mean, dimension? 2D shape and 3D shape. Yeah, any takers for that? 2D shape and 3D shape. Anyone, any takers for that? Just waiting. Only 2 dimensions in 2D. Yeah, that is very obvious. 2D is called 2D because it has 2 dimensions. But what are those 2 dimensions? In 2D, we are able to see in 3D, we are able to see the third direction. Third direction is a little bit vague term. Kindly explain that further. In 2D, we have length and breadth. Okay. Okay. Naresh, in 2D, 2 axis. And in 3D, 3 axis. Okay, 2D and 3D. You can explain it that way. Okay. Can you explain that in terms of the motion of an object? Yeah. That is okay. That is the representation of 2D x comma y and 3D x comma y comma z. Third physical dimension, length, breadth, and height. Yeah, most of you see, whenever we talk of 2D and 3D, you talk in terms of length, breadth, and height. So basically, two motion, when you have to tell someone 1 dimension, 2 dimension, and 3 dimension. 1 dimension is basically when an object is moving on a straight line, then only 1 dimension is changing, that is the length on this line. But when we talk of 2 dimension, see, this is motion in 1 dimension. When there is a plane and an object is moving on this, then it is 2 dimension. And when motion is in air, that is the space. Now this is an object having volume. So whenever there is something moving inside this in the air, then this motion is 3 dimension. So for representing 1 dimension motion, you just require single axis, that is the number line. For representing motion in 2 dimension, you require a plane, that is Cartesian plane x comma y, which one of you just not said. And for representing motion in 3 dimension, you require space. So that is x comma y comma z. Height issue also comes in that. So most of you got that right, but little bit explanation part was missing. So I understand that on chat it's quite difficult to explain that. So all these figures have heights, therefore they are called 3-dimensional shapes. So viewers, thanks for participating in this live stream. The first live stream, we had a lot of viewers because that was pre-planned, but unfortunately due to a technical failure that got stopped. We'll have one more live stream tomorrow for this important topic, and I will be doing 5 important problems which you have to do in surface area and volumes chapter for class 10th and obviously for every competitive exams. Right? Till then, Keep sharing the channel and subscribe the videos if you like it.